So we'll continue on with our discussion about continuous functions. Some of your homework is going to just be recognition of types of functions that you have, and then stating whether or not those functions are continuous. So you'll need to be familiar with these ideas. Polynomial functions and the trig functions cosine and sine are continuous at every point. So a polynomial function, something like x squared plus 2x plus 1 for your f of x, that would be continuous for all real numbers, continuous at every point from negative infinity to infinity. And likewise, anything involving the cosine function or the sine function, cosine of x or cosine of 2x, sine of x over 4. All of those are continuous at every point from negative infinity to infinity. Rational functions, those would be your fraction functions. Those are continuous for all points except where the denominator is equal to 0. So you have to be aware of what a question is asking. If a question is asking about whether a function is continuous at a point where the denominator does not equal 0, then it is continuous. You just have to pay attention to what x value is being considered. And then radical functions. Radical functions are your root functions, like a square root or a third root. Those are continuous for all points where the domain is defined. So for third root functions or odd root functions, that would be from negative infinity to infinity. For even root functions, particularly square roots that you'll be looking at, remember that negative numbers cannot be in the radicand. You can't do the square root of a negative number within the real number system. So you have to pay attention to where the domain is defined for radical functions. And then finally, your trig functions, tangent, secant, cotangent, and cosecant, those are all continuous between their vertical asymptotes. So you'll need to know a little bit about where those functions have those vertical asymptotes. So I copied 3 graphs that were taken from your textbook, and you're going to be answering some questions, as you can see, parts A, B, C, and D for each one of those graphs. But I felt like the author of the textbook missed the most important point of each one of those questions. And so we're going to make a conclusion based on our answers to parts A, B, C, and D for each one of these. And I'll have you do that same thing in your homework. So the first thing that I want you to see in each graph is the C value that is being considered. So in graph number 1, and it's maybe a little bit hard to see, so I'm going to put a box around it. Your C is -2. So we're looking at this graph being continuous at the C value of -2. Well, the first thing we're going to look at is part A, the limit as x approaches C from the right. So, and that's what this little plus sign means. So I'll put right there, from the right. Well, so we would look at, as we're approaching -2. Now remember, I'm looking at the x value. So as we are approaching -2 from the right, what y value is being achieved? And hopefully you can see that that is a -2. Now that's the y value. And then we're going to look at x approaching C from the left. That's what that little negative sign means. So from the left, and so we'll look at, as we approach -2 from the left, what y value is being achieved. Again, it's -2. Well, based on the theorem that we stated at the end of our last video, we said that if the limit as x approaches c from the left and from the right are the same, then the limit exists and in fact is that value. So the limit as x approaches our -2 is our y value of -2. All right, so that now satisfies one condition of continuity at -2, and that is that the limit exists. Part D is asking, what is f of c? So in other words, for this problem, what is f of -2? Well, there you actually want to look at the ordered pair. So what is the ordered pair when x is a -2? Well, the y is also a -2. That satisfies the second condition of continuity, and that is that f of c is defined. It is. It's -2. The third condition is that the limit as x approaches our c has to match f of c. And so I'm circling C and D parts for you to show you that that is indeed true. The limit as x approaches -2 equals the value of f of -2. And because that is the case, in part E, we can state that f is continuous at x equals -2. And that would be the conclusion I would want you to make from those types of statements. So we'll look at another graph. Problem number 2 has our c value that we're interested in of -3. And so we will look at the limit as x approaches -3 from the right. So this top one is from the right, part A. As we approach our x of -3 from the right, what y value is being achieved? Well, actually, the y value that we're getting is 3. And then we'll look at x approaching c, -3, from the left. What y value is being achieved? Well, again, it is a 3. So, since we have the limit from the right and the limit from the left, both equaling 3, we can conclude in part C that the limit as x approaches -3 of that function is 3. So our limit exists. Then in part D, we'd like to look at what is f of c? What is f of, in this case, -3? Once again, we need to look at what is happening to our graph at -3. And so now you want to look at the actual defined ordered pair. Well, when x is -3, that ordered pair is has a y value of 4. So f of -3 is equal to 4. So our second condition is met. F of -3 is defined. Our first condition is met. The limit does exist. However, the third condition, where the limit as x approaches c of f of x is supposed to equal f of c, that is not met. These two values are not the same. And so our conclusion is that f is not continuous at x equals -3. F is not continuous at x equals -3. And then our third example from this section, we have, hopefully you recognize this as a piecewise function. Our C that we're interested in is -1. So we'll look at part A, the limit as x approaches -1 from the right. So as x is approaching -1 from the right, what y value is being achieved? And hopefully you'll see that that y value that's being achieved is 0. Then we could look at part B, the limit as x is approaching -1, our C value, from the left. Well, from the left, what y value is being achieved? And that would be a y value of 2. So now I want us to look at part C and ask, what is the limit as x approaches -1? Well, since part A and part B do not have the same answer, then that limit does not exist. Now we can go ahead and answer part D. Part D wants to know, what is f of C? So what is f of -1? So we can look at that. We have to look for where the actual ordered pair is. And that ordered pair is filled in for -1 at 0. So f of -1 equals 0. And then finally, we want to make our conclusion. Well, our conclusion for this one actually could have been made from the very beginning, because the limit as x approached -1 did not exist. And so therefore, f is not continuous at x equals -1. And it actually violates it because the limit does not exist. And if you needed a reason, that would be enough to stop right there.